All right, so I'm just kind of recapping what I think we did yesterday. So technically, to get back to the quantities, sub it into one or the other, or preferably both, as we learned, to double check your work. Right? So sub P star back into one of these equations. And so if we take QS equals 40 times 100, we get 4,000. And so that implies equilibrium quantities 4,000. That's about where we left off last time. And then we started looking at the shifts and we found out a little quirk with how we graph and how we show these equations. Okay, so the story that we told in principles class is that quantity is quantity supplied, QS, or demanded, QD, is the independent variable. I'm sorry, the dependent variable. Get rid of that N. The dependent variable. So generically, how we'd write that is to say, for instance, the quantity supplied is equal to some function of price. Right? So quantity supplied, we know what that one is, hopefully. Quantity supplied. This is a little bit of interpretation of math when we get into it, and I did a little bit of this in principles class. So is, got our decoding glasses for the equation. Quantity supplied is a function of market price. So in other words, price is the independent variable. So when we think about the demand curve or the demand function, this is the story we're telling, is that, hey, people make decisions on how much they're going to bring to the market based on the price they think they're going to get, or the price that they're currently getting, actually. There's other things that factor into this function that we're ignoring right now. So that's our ceteris paribus. So inside this function, if we were to make a more elaborate supply function, we might also have the price of resources. Right? So we might have the price of resources, the current wage. So we're currently paying people, we can hire as many people as we want at McDonald's for $8 an hour. So the wage, the prevailing wage, might be another price that determines the quantity of McDonald's hamburgers that are supplied. So there's other arguments that are independent variables that could play a role in how much quantity is being supplied. Right now, we're just going to look at price and think about the simple setting, the simple equation here, the way we've got it, is that the quantity supplied is dependent upon price in this particular setting under our ceteris paribus assumptions. All right, questions on that so far? So what we alluded to last time is that if we were to graph that function, we always graph it like this. Well, when it's of this form, the y and the x, if we go back to y and x's, which I don't like to use in general, so I'll quickly get away from this, but this is kind of to bring back some math here. And we think about y being equal to mx plus b. I know there's other ways to write that, but that's our slope term. So if we think of slope and the intercept, that functional form with graphing goggles on means that the y is the thing being measured on the vertical axis. And that's what caught us yesterday, or on Monday, when we were thinking about that intercept of 400, which is part B of this problem, right? So y is to the left, all the other junk is to the right, and when you do it that way, this is the setup. So the thought here in math class is that x is the independent variable, and y is the dependent variable. And now it makes sense. If we take this function, this is the dependent variable, price is the independent variable, then we'd be writing it with Q here and P here. And then our math worked out. So basically, just remember that the demand curve and supply curve framework, that market system where we tend to measure price up here, goes against math history and math logic the way we normally do things in math class. Alfred Marshall kind of created a historical accident that stuck. Because technically, there's no reason we couldn't draw supply and demand with the Q here and the P here. There's nothing wrong with that, right? I mean, think about it. You get an upward sloping supply, and you get a downward sloping demand. We could work with that. It just stuck. He did it in the 1800s, and people started following that, like, oh, that makes sense, that makes sense. And before you know it, you created a monster that you can't undo. So it never got undone. And here we are today in 2012, still doing the same thing, and now we have to explain to new students to economics of why we do it in kind of a messed up way. Okay, questions on that? So, so the demand curve and the demand function, in a sense, are a little bit different. So let's rewrite a couple of these here. So quantity demanded equal to 5,000 minus 10p is the demand curve. We can always take this expression and throw the junk over to the other side. So I'll do it in a couple steps here. 10p equals 5,000 minus QD. And P equals 500 minus 1/10 QD. We're going to call this the inverse demand curve. So we didn't bother to go through the details in principles class, but what we were always graphing was the inverse demand curve. Inverse in the sense that it doesn't follow the math logic of dependent and independent variable. That's why we're inverting it and then graphing it that way. All right, same thing with supply. So QS equals 40p in this case. So this is the supply curve. junk around, we get this. And that is the inverse supply curve. So, it's possible to take these two equations and set them equal to each other if we believe that there's going to be one price at the end. That's kind of thinking about it backwards, but the math would work out just fine. No problems there. Solving for QS, what we're essentially saying, if we solve this way, so this is maybe an extra little note here. You can solve for Q, since we know in equilibrium all these things equal. And so we can take this equation. Let's label these equations 1, 2, 3, and 4. So if we solve for the quantity, we could set 2, we can set 2 equal to 4. Set equation 2 equal to equation 4, since we got two p's here that we know are going to be equal to each other. And out's going to pop Q equal to, if you go ahead and do that exercise, you're going to find Q equal to 4,000, right? 4,000? So you can go back and forward using the inverse demand curve or the demand curve to get to the same spot when we try to solve for equilibrium. Okay, part B. Part B. So I want to have a gut check first. So suppose, go to part B and read that. Suppose that a severe frost raises the price of lemons, causes the price of lemonade to rise, the price of resources. The question asks, in response to increased cost, producers reduce the quantity supplied of lemonade by 400 pints at every price. What is the new equation for supply of lemonade? So when you go into problems like that, I recommend that you draw a quick graph, because I think that, for instance, is what helped Brinson out to uncover our little issue we had. So my philosophy is there's always a status quo, so hopefully you've got home base memorized. For just about any problem, you should be able to draw a graph like this. I don't care if we're talking pizza, beer, orange juice, lemonade, lawyer services. That's our home base. There's some starting place in this particular market. We are in the market for what? Lemonade? So this is the, we could put a little L here, price of lemonade, to remind ourselves of the good we're talking about, especially when we get into part B where it says the price of lemons go up. I want you to be really crystal clear that, hey, ultimately my question is asking about lemonade, not lemons. So maybe an L's not good enough. You might want to put lemonade or whatever. Just make sure that mentally you're in the ballgame of what we're talking about here. And so from a principles analysis, what's going to happen in this market? Supply is going to decrease. And what's going to happen to my axes, variables? Price goes up, quantity goes, equilibrium quantity goes down. have that gut feeling, like do that principles analysis right out of the gate. And so we need our math to kind of fit that, if we're comfortable with this. Of course, if you're screwed up with this and you thought that that was going to increase the demand or something, then that's not going to lead you to the right place, right? So you might have to go back and forth sometimes too, because I realize I'm not even expecting your principles analysis to be pinpoint 100% accurate at this point. So, but that's the idea. So, part B, I think we got to this point. We had a decrease by 400 pints, so the quantity supplied equaled the 40p minus 400. Okay, so what is this P1 here, or P2? Anybody solve it out from yesterday? What'd you get? 108. Okay. So 108, how'd you get that?
Pretty much you have your quantity and your quantity dependent equations to the same. So each equation equals each other since the same.
All right, so we're gonna set. This is the type of stuff we're going to be doing here. We're going to set equation star equal to equation 1. Right? This will be our shorthand. Set star equal to equation 1 and solve for P. So now we just have that extra term in there. Set those equal. Let's go ahead and work this out. 5,000 minus 10p. I did it a little bit backwards here the way I wrote it. 40p minus 400. So we get 30p. You guys can catch me on errors if you've already wrote this up. I already have one?
Yeah, it's 50p.
Oh. Oh yeah, that's going to add. Good. 50p equal to what? 4,600. These are going to be going 5,400. All right. And so P equals 108. So again, 108. Now we can kind of come and see if this makes sense. We had 4,000. We're not quite done yet because we need to find out what the new equilibrium quantity is. Again, drop that back into one equation or the other, or both if you want to double check your work. And so we get Q star. We can again pick either one. Equals 5,000 minus 10 times 108. And what does that equal? 3920. So quantity falls to 3920. Okay. So any last questions on that one? Yes.
So if you wanted to plug it into one of the P equations, that's when you rearrange the quantity supply equals what we find you rearrange it for P, so it matches the graph.
Right. Essentially, because we went through all these steps, and there's going to be multiple ways to come to the answer, and so it's not always you might come up with a regimented way that you like to do it, but the problem might present itself such that you really need to. It'd be best to work with. It'll be easiest to work with the inverse supply curve rather than the supply curve, right? So but there is multiple ways of coming to it. So if I'm understanding you right, we could have shoved Were you were wanting to use this equation essentially and solve for P? Yeah, and you could have if we worked it the other direction and substituted in that. And then these are all good double checks then. If we take 3920, shove it into here, 3920 divided by 40 should give us our 108. So yes. I did more to this problem than what you had to do to get the answer. So I've kind of fed you the different ways to look at it. I think I hit just about every way by manipulating each curve, showing the different functional forms, and then hitting it different ways. And there's different ways you could chunk through that too. Okay. What you got, Chelsea? Speak up. Let me hear. Have to add 400 instead of...
To the original P equation because we, for the new.
Yeah, that's a good point. So that which is kind of maybe counterintuitive, right? I mean, you're just kind of doing math rather than doing econ in a sense, right? I mean, you're right. That's how you would manipulate the question. But to me, as an economist trying to work through the logic of how the market system works, that doesn't quite make as much intuitive sense. Mathematically, that's the correct thing to do. But you might want to here, okay, producer wants to make this much at each price. Now they want to make 400 less at each price. The math kind of speaks a story to me rather than just hitting the math, but you're absolutely right.
Okay, well maybe I asked the wrong question.
Okay.
Because I got that answer, the Q equals 4P minus 400, but then I rearranged it for P.
Okay.
And then would I plug it back into the Q equation or?
Oh, I thought you were then subtracting the 400 from that, which would be what you were bringing up, Chelsea, right?
She's
Okay.
You still
So,
like for this answer, you have to add back the 400 to the quantity demanded or the quantity supplied. In those equations, for it to equal 108 or something.
yes.
oh, the 108. Yes. I guess I dumped this into here without the 400, didn't I? Is that what you're bringing up? Because I did. Now I think maybe, I don't know. I took this answer and said take this divided by 40, but I didn't take the 400 into account, right?
She was asking.
Okay. Should we start over? Go for it. Is it good? Are you clear or not? Are you sure?
Yes.
Okay, because I'm not. I'm at least not clear on your question, but if you kind of sorted it out, great. All right, anything else? Okay, so that's a dose of the math. Let's think about the things that'll be in your notes when you go back. So we're going to have a little principles recap, almost like a review session. And we did some of this before. So I'm going to give you the short of it here. Law of demand. Increase in price leads to a decrease in quantity demanded. Trying to stay consistent with the textbook here. Quantity demanded. Ceteris paribus, holding all of the things constant. Law of supply. Increase in price leads to an increase in quantity supplied. Ceteris paribus. So that intuition reveals itself with a positive slope on the equation. And the arrow's moving a different direction here would be a negative slope. demand shifters. Let's hear them. What are the things that influence your purchases other than price? Price we've already handled with the law of demand. So what gives you your demand for, start thinking of goods that you buy at Walmart or things that you want. Expectations is one. Price of related goods, good. Now we're starting to get going here. So expectations, price of related goods. Let me pause on related goods for a second. How are goods related? Complements and substitutes. Yeah, Rhiannon's got that one down. Right? I can show you. We can go through a short little video that some of you saw on it. Now, complements has an E in it, not an I. And I'm not picking on spelling, but this one kind of helps mentally. You're completing a set. Peanut butter and jelly go together. Tennis rackets and tennis balls. It completes the set. You're kind of, and we're going to get into more complicated models of pricing where we're bundling things together. So bundles of goods. And so the complementarity of goods is important. All right, complements or substitutes. So Coke and Pepsi are on the substitute list. We can put PB&J on the complement list. What else? Market size. So that is the number of consumers on the demand side. With the supply side, it's going to be the number of suppliers. So the number of consumers or the population. So an increase in the population leads to an increase in demand. There's just more bodies there to have to deal with. Number 4. We're kind of missing a big one, and it's kind of an easy one, I think. Technology is on the supply side.
This is more so the
This is the demand curve.
no, I'm thinking of non, like, I don't want to say natural disasters, but what is it?
Yeah. Natural disaster thing usually goes with the supply curve, but it could be go through what did they need in Haiti or in Louisiana with the floods, with the recent hurricane. I mean, the demand for what goes up a lot when you get these natural disasters. The necessities like food, water, especially water, right? But food, all kinds of supplies, all of a sudden the demand for that stuff goes up. Their tastes or preferences for those goods has changed because of their circumstances related to the natural disaster. If it's raining out, our taste for umbrellas all of a sudden dramatically goes up, right? So tastes and preferences. If something's in style, everybody else is doing it. It's kind of a generic one that captures a lot of things that pertain to advertising, of why companies advertise, to change your preferences, your tastes. It might just be knowledge. You don't know how great this product is. Once you learn about it, then that can increase the demand. We're missing the big one. Pretty good, though. You guys are doing good. Expectations, price-related goods, number of consumers, taste or preferences. Bud Light, Keystone Light, ramen noodles versus fancy dinner at Olive Garden.
Income?
Inferior goods, and most of the time our income, yes. When we have more money, we tend to buy more things. So most goods are normal goods.
This is a dry canvas.
An increase in income leads to an increase in demand, a shift to the right for a normal good, which is most goods. But things like maybe ramen noodles or hot dogs might have the opposite reaction. As you become richer and you have more income, you buy less of those generic brand goods, inferior goods. Okay. Supply shifters. Supply shifters. One was technology. Two was number of suppliers, these are just ones that we already mentioned. 3 was on our example. What was that one more generically? The increase in the price of lemons led to the price of resources. So more generically, the price of resources, which ultimately is the cost of production, right? So the cost of production. Four, we kind of said already too, expectations. Well, government policy can affect it, but that usually is through price changing it. But yes, we learned that taxes can shift up the supply curve, but it's kind of like a fake supply curve, but is the way I play it out. But it could be added as showing it that way. The reason I hesitate to do that is because you'll get the same result whether you tax the consumer or tax the producer. So a tax all by itself could have different implications. 5, the price of related outputs. So we've got 2 cases again. They could be substitutes like wheat or corn for our farmers. Should I produce wheat? Should I produce corn? The 2 are related. The 2 are substitutes. Goods can be complements in production as well. So I like to think of honey and beeswax. All right. Be real helpful to have this list memorized, just like you needed to have it memorized for principles class. I didn't put on every single relationship. We'll kind of work through that as we go through problems like this. But for each one of these shifters, if there's an increase in the price of peanut butter, what happens to the demand for jelly? It goes down. Because the bundled good, a sandwich, now costs more if peanut butter went up. So I'm going to start making some turkey and cheese sandwiches instead of peanut butter and jelly sandwiches, right? So the demand for jelly goes down. So there was those relationships that gave us the qualitative directions of the change. Okay, call it a day there.